I'm going to make you a host. You can do the sharing.
Okay.
Yeah, James.
Cool. Okay. Let's wait for a few minutes if more people join. If not, then we can start. I think we can start with a quick background first on what's going on with the Fungible Token Standards. And later we can go into the new proposal. So we have originally had NAP 21 standard, which is mostly a port of ERC20 standard from Ethereum to Near without much changes. So it supported allowance and two methods, transfer and transfer from. But because the Near, there's two significant differences compared to Ethereum. First, it's asynchronous, which means the environment in which you call another contract, first of all, can be done in parallel. So a token contract can be called in parallel to your call to this contract. So the state of this contract can be updated in the meantime while you're calling it. And the second, it's a revertibility of the state. So on Ethereum, you can revert state from the within the call. It's more like a transactional, where at the beginning of transaction, the state is snapshotted, and like all the changes while the transaction is happening is kind of in a temporary view. And at the end of the transaction, or at any moment within the transaction, you can revert all changes and cancel this transaction. That includes state changes from all contracts that you touched. On Near, you can only revert your own state and only during this particular call. So if you call some other contracts a synchronous promise, then you'll have to commit your own state. And then you will not be able to easily revert it unless you called again. The second difference is storage staking. So the idea is your contract, the token contract has to cover entire persistent state of this contract. So if your contract is one-to-many, meaning it supports multiple users, or per user you support multiple data, you have to cover all the state from the account balance of the contract. So the previous contract was not only one-to-many users, but also every user might have different storage because of allowance. So allowance is from user to multiple, what we call escrow account IDs, so to multiple contracts. That created a problem with the balance that has to be attached every time you increase storage and has to be reverted or like refunded when you decrease storage. So let's say you withdraw all the tokens using transfer from some account, and allowance became 0. So in this case, we can potentially delete this account, so the escrow or like a contract that did this transfer will receive the tokens from the user. So the original standard map 21 had two issues. One is unpredictable payments of attached balance, and second, it created slightly more complicated composability because transfer from did not guarantee a success. You need to handle it and do reverse, plus allowance is kind of abusable if you like over declare it. So the new standard proposed originally by Robert, I think he joined us. It's 136. So this standard is more like a subset of this, and it's like an adopted version. We also had another standard proposal, which was 122, which requires some extra logic on a contract in a state for the duration of the transaction. So this particular standard is only covers the transfer and balance API, and it does not cover two extra requirements. One is account registration that you use for storage allocation, and second is metadata that you will use to identify the fungible token contract itself. The reason why we do not include it because account registration is a common standard for NEAR that will likely to be reused for multiple contracts and not only for fungible tokens. So, so let's say you work with one-to-many accounts, then you likely will have to use account registration standard because you need to cover the state of users. And second, for metadata, metadata can be upgraded in the future, but the core API doesn't have to change if you only change the metadata. So let's go through this standard and explain the flow. So we will review JSON API, which is language independent in some way. I used TypeScript to define the JSON API, but probably be defined as pure JSON in arguments. But let's, this is also simplification comparing to Rust because it doesn't use custom types such as like account ID or U128, and instead uses just strings. So the first is naming. There was suggestion and proposal to use prefix of FT, stands for fungible token, underscore for all methods related to fungible token. And the reason for this is we want to distinguish this standard from some other standards. So for example, if you would ever implement OpenSea that works with stablecoin potentially, then maybe this contract will have to handle both NFTs and fungible tokens. And well, it's kind of, it will be on the receiver side. But anyway, it kind of helps to distinguish between future standards such as like a fungible token or lockup contract in the past that also has a transfer method to indicate that this is related to fungible token and this particular standard. So let's say we implement a future standard, maybe we want to have some different prefix. I don't know. So fungible, so transfer, how this API is structured is first it's saying whether it's a change method or view method. Change method requires it to be called through a transaction, and a view method can be called through transaction, but also through a view call. So view calls are kind of RPC call that is free and can be executed by any node that tracks the shard, not necessarily the validator node. And the change method can only be executed by a validator node on chain. And it's also requires to pay gas. Okay, so then it's a general description of what the method does and logic of it, then a bunch of arguments and a return value. So this is a kind of high-level name for the method. So let's start with the transfer. So transfer is similar to NEP21, except we add an optional memo field. So if you upgrade your previous token standard to this one, all the previous APIs, well, actually no, because of prefix, it's not gonna work. But so we use argument for account ID called receiver ID. This is more like a standard way for near protocol because we use receiver ID in transactions and receipts. Internally on the protocol level, we also use receiver ID for the destination. Then amount, because it's a JSON, it's saying it should be a positive number in decimal string representation. So we assume that the amount should be limited by U128, but this is actually can be debated whether we want to limit the amount. I think it's reasonable to limit it to U128, but at the same time, if we go, for example, to Ethereum tokens, they all use U256. And JSON does not limit us in size of the decimal representation, but at the same time, we probably should restrict it to U128, at least for this standard, because all the tools currently do not work very well with U256 unless you manually handle it. Does it make sense to actually restrict it to U128 in the standard?
Well, we can make it as a recommendation. As you said, like this is a string, so it's variable.
If you do not restrict it, then maybe some tokens implementation or like a receiver of the token will assume this is U128, but it will fail if some other token implements U256 transfers, and even so, it will be considered a valid standard. So I would suggest we say that the maximum amount is U128, at least for this particular standard. What is
I think it won't change. I mean, it won't change the API. Yes, so the API will stay exactly the same. It's just the validation code in the contract.
Well, in general, it should be handling of these numbers.
Yes,
So-
but it's on the API level. It's string. So
Right.
So I mean, either you put 128, you put like any other string wrapper. It won't matter. Yes, on the API level.
Yeah, on API level, no, but we can define or like restrict it on the standard. So saying that the amount should be at most U128, and that will kind of restrict the standard from, to be considered valid, the amount should be always like within the range. Otherwise, it will not be a valid contract implementation for the standard.
Yeah, but it will comply with, let's say, I mean, still, if somebody will choose differently, if somebody will choose U256, it will be compatible, right?
It will be compatible, yes, but it's kind of like some, let's say if you implement near swap that is generic for like all fungible tokens, like have a factory, then if one of the contracts tries to use U256, then at some point you will face a problem where you're trying to deserialize U128 and it would throw like overflow, like truncated. Okay, this is what Robert suggested to add to every transfer. And the idea here is very frequently you need to attach some kind of message or memo why this transfer happened. So like what's the reason for the transfer or some kind of regulatory reference for this transfer. And memo is the field you should put it. Once we have events similar to like EVM events, memo will go to event as well. Potentially, or truncated memo, depends on like limits. Okay, it's optional because I assume majority of like automated transfer will not have any memo. And putting an empty field versus like null, it's kind of just a trade-off of implementation. And if a contract relies on memo, then it's fairly easy to just initiate it with the empty string if it's needed. Okay, next is the most interesting method of this standard. So it's a transfer to a contract instead of a regular user. And it requires a contract to implement a specific receiver API. So it will, the way it works, it transfers. So here's the method. It has one extra field message string. And the way it works, it initiates a transfer and completes it by depositing the amount of tokens to the receiver account first. Then it creates a promise to receiver ID that calls method ft on transfer on the receiver's contract. And it passes who sent the tokens. So it passes the sender ID. Then it passes the amount and message. So message is passed through string that will be given to receiver. Now a receiver receives this call and should reply with the amount of tokens that it intend to keep from this particular transfer. So it should reply from 0 to amount. If then once a receiver completes a reply, a callback is executed on the fungible token, and it should handle the execution of the result of this promise on the receiver. So if receiver returned a valid value from 0 to amount, then the difference should be refunded back to the sender. So the example here.
Eugene, can I make a comment?
Yes.
Can we invert that? Because we are returning an amount, can we return the difference directly? So if that will be more intuitive for everyone.
So if you basically, in order for you to refund this difference, you would need to schedule another promise on the fungible token.
I mean, we are returning how much we used. I propose to return how much we are returning. So it's the same idea. Return 50 instead of return 450.
I see. So basically, it will always return 0, right? In this case, like if you want to consume everything.
Yes, correct.
So why this is better than returning the amount consumed?
Because you are the word you use return. The natural
I see.
Identification is the amount you return.
I mean, I
could go either way.
Big difference. Yeah, well, it's kind of similar.
I think it's a matter of taste. I mean, I don't see that like the whole world is using that methodology. If you say that, Lucio, I was wondering which one is better, and I couldn't find which one would be better. But I mean, yes, sounds kind of logical that you say, okay, return this, but it doesn't mean really like the function return doesn't mean what we need to return.
Mm-hmm. Also, it feels like from contract implementation, it might be easier to just say how much you actually spent. So, so if you, again, the reason why you would actually do refunds through this is, let's say you have a token contract, let's call it DAI, and then you have a Uniswap that works DAI to near. And when you call swap method on Uniswap, the way you would do this is you would initiate a transfer call to Uniswap, and you would pass a message indicating you want to swap and parameters of the swap. Then you would attach amount of, let's say, DAI, slightly higher than the amount you need to receive in near. So you say, for example, I desire to get 50 near. Here's the amount of DAI, slightly higher to cover for potential price slippage in between. Then your message received on FT on transfer, it computes how much DAI you actually need to spend. It verifies that this DAI is lower than the amount you attach, and then it just returns the amount of DAI you spent. when you return like the amount to refund, it's pretty much the same. You just say you need to like amount minus this to compute. When you say how much you spent, you just return the value, like how much value actually cost you. I don't have a strong preference. I feel like return value versus return like refund is not really like same thing. So changing it doesn't make a big difference. Then it also
Look,
I
how,
suggest
look how you write it. The transfer amount was 500. The contract completely takes it all and should return 500. Do you understand that you're using the same word for two different things, and most people don't read the documentation, so everybody will trip on this. If we inverse that, is the same, you have to do a difference. You either do it here or in the receiving call, and it will be easier to explain. Somebody not reading the documentation will do it fine on the first try.
Well, there's another value that should be returned. So FT transfer call will return the amount of tokens actually withdrawn from the sender account. The way it works is once you actually calculated the refund, or like the amount of token consumed by the receiver, and refunded the rest back to the sender account, you return the amount that was used by sender account.
I think maybe we can take
So this is done in a callback.
I think this is an interesting idea. Like, we have about a half hour. I do like have other like philosophical questions. Do you guys want to like take this suggestion and bring it up more in the standard?
Okay, let's basically not change the API right now and come back to this. At least if it's only a wording problem, then we can figure out how to make it properly explained in the document.
Okay, if you want, I can write a comment there. It's not a wording problem. It's an intuition problem. There's a lot of people that don't read
intuition or
documentation.
explanation.
Okay, imagine that you don't read the documentation. Okay, no
Still
problem.
will be like it's a
Let's
used amount, so you need to like return a used amount, not a refund amount. And let's explain it here, right? I mean, okay.
Well, we can do a poll or something. I don't think, for me, it's really a matter of taste. There is no.
Okay, let's
continue.
Let's continue and come back to this if we have time. Otherwise, we'll discuss this asynchronously. So there's security concerns regarding this transfer compared to vaults, and we discussed this in this standard in this issue, but let's just reiterate on this. So basically, if a receiving promise fails or returns an error or invalid value, we consider this transfer to be not received, and we refund tokens back to the sender in our callback. So this this prevents you from locking your tokens through a transfer to some contract that does not support it, or if you didn't attach enough gas for the transfer call. and the receiver cannot just handle it. Or if it like implements an invalid API or some bug happens on the receiver side. So basically your tokens are not gonna stay at the receiver's account because the callback will refund them back to the sender. Now, a second security issue, if the receiver contract is either incorrectly implemented or it's malicious, then it can withdraw more tokens from its balance because it's already had them on the balance, and then return some value that requires it to do a full refund, for example. So it can spend the tokens and then maybe panic. No, it cannot do, well, kind of. So in this case, it's not a problem really for the sender, because when sender called this action, there was some guards already in place by the sender. First account has to already be registered. Second, the contract actually has to do this. And it's a mistake on the sender side to use a receiver contract that is invalidly implemented. And the most amount a sender can lose is their transfer amount, which is you intend to spend it when you actually attach it. So there is no really an issue from the security perspective of a whole token compared to this particular transfer. Plus, a receiver cannot overspend their balance. Like they can only spend their own balance, not the sender extra balance, such as like throw amount. So there's no reentrancy attacks or anything like this. And that's why we don't really need vaults or like temporary restrict the storage only to this particular, because if a receiver still wants to overspend their balance, they could do this even with the vault standard. At the same time, this logic does not require any temporary storage on the fungible token contract implementation. Plus, it does not require a receiver contract to do the withdrawals through a promise. So it also simplifies the receiver side. Now, I haven't mentioned this particular part from the simple transfer. So the idea here is the way access keys on Near work is there's two versions of access keys. One is full access key that has full permission to the account, so you can call any method. And second is a restricted access key, a restricted function call access key. It allows you to, from your account, call a specific contract. And all methods, or like a restricted set of methods specified by on the contract. But it does not allow to attach deposits through this restricted function call. So you cannot spend accounts balance when you do a function call. And we use this function calls for DApps. So when you authorize in a DApp, so for example, on the Berry Club, you log in, it creates access key that is specific only to this particular contract. So for example, you have a Berry Club contract, and when you log in, it creates an access key on your account that goes towards the Berry Club contract. And it allows to now the front end of Berry Club to issue transactions towards the Berry Club contract on your behalf without you having to confirm every single transaction. So it simplifies the UX and like usability of the DApp. So why this is relevant for this? So if you go to some DApp and log in, but instead of authorizing their contract, they will authorize a fungible token contract. So let's say it creates an access key, tries to create an access key to like a bridge DAI contract. Then it would be able to just issue FT transfer call without you having to confirm this fungible, or like this contract call on the front end, and it can drain your account. This is problematic because we're trying to simplify security of Near by saying you can safely log into majority of contracts. It's also a problem on the wallet side. So wallet should probably prevent you from authorizing DAI if it knows about DAI, but if there's some kind of contract that is not in a tracking whitelist or like security contracts of the whitelist, and there's no metadata right now to tell wallet about this, then it will allow user to actually do this. Now, that would allow the malicious dApp to withdraw entire balance, for example, from the particular contract that it got the authorization from the user. Solution for this, for temporary fix, is we say some contracts may be willing to implement a security measurement, which saying you have to attach at least one octaneer for this particular function call in order to this method to work. So one octaneer is less than a gas amount, a single gas amount, so it's not noticeable from the spend perspective, but it will prevent access key from executing it. So this standard actually does not say you have to attach one octaneer for every call, but at the same time, it's saying that this particular method should be marked as payable in Rust, which means it should be able to accept deposits. And I would recommend to put a one octaneer requirement in majority of fungible token contracts. That will prevent the abuse at the same time.
There's some reason why you don't want to add this to the standard of one octaneer. Do we plan to change that in the future, or I'm curious? It seems like we should enforce security. Like
so basically say you need to attach one octaneer exact, for example.
That seems to make sense to me. Do other folks have thoughts?
Well, how would clients know whether the contract, I mean, we'd have to know that specific token. If it's not, we'd have to know whether it requires it or not.
Yeah, so what
It
Mike is saying,
it wouldn't be generic unless it was part of the metadata. It's somehow.
All tokens
So
will
what
be
Mike is
one
saying,
octaneer. There's a
Yeah,
to enforce it.
Then the near security is not working. You need to fix that. The near security model of calling functions is not working for fungible tokens. Until they fix that, all fungible tokens will need one octaneer.
Okay, yeah, we can enforce this. I mean, one octaneer is not an issue anyway. So the only question is, do you ever need to implement a DApp that does not require this one, to octaneer? Like you actually want to be able to like call transfers as fast as possible from the front end, for example, without having to confirm every transfer through a wallet. If the answer is yes, there's still a workaround. You can implement another method, like a proxy method that will just wrap this FT transfer call with a method that attaches one octanere, and this way you don't need to attach octanere. But yeah, okay, yeah, that's a good point. Let's enforce one octanere deposit on these two methods until we fix the issue in the wallet. Now, again, this method takes memo, but it's not passed to the receiver side. So a receiving contract will not get the memo. And if you need the memo on the receiving side, then probably it can be included in the message. So finally, method is two view calls. So it's a total supply and balance off. Oh, I didn't update this. I need to update this. So the only comment on balance off, if the account doesn't exist, the method doesn't panic, and it should return 0 for non-existing accounts. That's easier to use when you have a logic to handle it. And a second standard that will have to do account registration will have a method to check if the account exists. So.
Could I ask a kind of bigger question here? Like, and maybe this is just on the implementation of someone, but sort of taking a step back, forest for the trees sort of thing. I think, Robert, and thanks for all the work and versioning you've done on this. I think part of this comes out of Robert working on like a near swap situation. And so the use case that we're kind of thinking about, at least I'm thinking about during this discussion, is like a swap interface. And now I want to kind of like think about what are the other use cases and, you know, the future of the open web that we all wish to see, and what are there things that we're missing if we don't have like an escrow type system? Because right now I can think of all these reasons why escrow is clunky, doesn't make a lot of sense. The future of the open web, like let's fast forward a couple of years, I would love to see something similar to like, I have my credit card on file for a subscription, like a monthly subscription. And so I do want to keep subscribing to this community and whatnot. Escrows are actually pretty useful for that. And I guess while that could be added to this standard based on, you know, someone's implementation, I want to make sure that we're thinking about all the reasons where escrows are used or are worthwhile, and bring that to the discussion for a second.
So
I mean,
that's a good question. I was
yeah,
thinking in fact about it. Like in general, what we are thinking about here is the transfer and the payment. That's the primitive we want to really implement. So I'm buying something, I'm offering something. Yes, I'm interacting. And so in general, whenever I want to interact with some entity, the subscription model you mentioned, I think is very limited, and that one could be implemented in a separate standard, not a token standard, but payment subscription standard. So that would be a different smart contract, an escrow smart contract, which will have allowance, yes, to or like spending allowance to another entity, and that would have limit. Let's say I would say that this guy can use maximum 100 NIR per month, right?
Yeah, I agree on this.
And there may be like many different options, right? You don't want to have like a single allowance, unlimited allowance, or a big allowance without these limits. And this shouldn't be a part of the token standard.
Okay.
Also, same way we don't have burn and mint on this standard because both of them are extensions. So if you have a limited supply token that doesn't allow burn or mint, then
Okay. So I have one strong objection. I already mentioned, talked about it in a comment. So in general, I don't agree about the FT prefixes. The reason I don't agree about the namespaces in the function names is because this is against the interface idea. The idea of an interface is that I want to describe some property. And if someone implements that property, then I want to use it. Adding these interfaces, it basically destroys that. So think about it. Think about like a mint function, right? Or a burn function. Now, if you will have ft burn, nft burn, or whatever burn, right? So as long as I can burn something which has the same interface, I should be able to build to use it, to use that contract. And I don't care if this is like particular fungible token, or maybe this is some escrow or whatever. If we will start adding these prefixes, then we use the generality.
But at the same time, if there's a conflict between two, and like for non-fungible token, there might be a conflict, then you will not be able to implement two interfaces if they have conflicting names. The reason we also have it is like in WASM and contracts, all methods are global, so they don't have namespaces that usually guard against this. So this FT is kind of our namespace for this particular interface.
Correct. Yes, but then probably like if you want to, well, like that's the whole thing about the standard, right? So the question here we should pose is there any, let's say, transfer function we would like to use with the same interface?
Imagine you want to implement a fungible token and non-fungible token all in the same contract.
They will have different interface because non-fungible token will have an ID.
Yes, but
Right, but
WASM doesn't discern the function from the arguments.
yeah, it doesn't
No.
have overload. Even so, in JSON we can do this.
Well, as far
Like
as I
because
know, correct me if I'm wrong. As far as I know, you resolve the function by the whole what's the name of it? By the whole header of the function, correct?
yeah, but like WebAssembly doesn't have the interface at all for the arguments. So like all of our methods, like on a lower level, is just like they don't return anything, they don't receive anything. So all the like parsing of arguments is done within the function. So in this case, we will have to try to parse either one or another, considering like input is either JSON or binary. There is extra gas.
I can still implement. I can have two smart contracts with the same function name but different arguments, and WebAssembly will differentiate it, correct?
No. Well, I mean, you can implement overloading of the methods.
I'm not talking about the overloading. I'm talking about the calling convention. So I'm calling someone else's smart contract. So let's say I'm calling, I don't know, contract a.transfer. And that function will be resolved by name or by the whole declaration?
By name.
By name, yeah.
Only by name?
But within this method, well, like Rust also does not support.
Rust doesn't support overloading, but I'm talking about two different smart contracts. So let's say you have contract A.
Yes, in two different smart contracts, if you have a trait, like different traits or like different interfaces, then you can, you can serialize it the way you want. But what we're talking about is same contract that implements two interfaces.
Yeah, but then
So
we
in
should
this
have
case, it has to handle.
Yeah, but okay, yes, but then we should have different name for that different interface. So let's say if there is another transfer with the same argument. Sorry, no. If there is another transfer function, right, with same arguments but different meaning, yes, then it should have different name.
But
Yeah, but
how
if
can
it's
you
part
how
of the
can you
standard,
invoke?
then you cannot. Yeah.
Yeah. How can you
If
invoke
it's part of the standard,
from the client,
then
from
you
the,
cannot. Mhm.
from the JavaScript,
Yeah, go ahead.
from the JavaScript client? How do you?
Well, this is what I'm saying, like that if it has different arguments, then sorry, if it has the same arguments, then it should have different name.
All functions must have different names, are only identified by their name. Their arguments are not part of the identifier. This is like classic C. You're thinking C++,
Okay.
and this is C.
Okay, I understand you. Yes, maybe.
Okay. So this is just the final piece. And the interface is it takes sender ID, which is a string, amount is a string, and message is a string. So the result is what we need to discuss, whether it's a used amount or refund amount. And it doesn't have to be payable because it can check who calls it. So you cannot really like directly call it, and it verifies that the predecessor is a token standard or like token contract that it expects to receive. And it's already have the tokens, so it can immediately spend them if they need to, but need to be careful of to not fail at this action. Otherwise, they might be refunded. And that's pretty much it.
I also want to mention one last thing, if that's cool, just to viewers who may not be familiar with like promises and async and how to think in a sharded, network and whatnot. So when we're talking about promises, so like we're going to say I'm a fungible token contract. I'm going to call another contract that I assume is going to do something reasonable with my, with this call, and then I'm going to kind of have a callback back to myself and see what happened. And you can say, I'm only going to use X amount of gas for this call to the other contract. And then you reserve gas for calling back yourself. So I think it's important to clarify that like if there is a malicious contract, they can't just do like a infinite loop and kind of burn all the gas and make it impossible to call yourself. You only have an allotted amount of gas that they can spend. So you can make checks to see if there's the proper amount of gas attached and ensure that this all goes as expected.
Well, I think that's a feature, right? So it's a user who decides about how much gas he is going to spend. I mean, there is a maximum limit. And the token contract will always have to reserve enough gas to call the callback.
Right, so callback is actually prepaid ahead of time. So when you do this implementation, callback will be prepaid. So your implementation will be safe because you attached enough gas, so long as you attach enough gas to your own callback. I think next step from this, let's summarize this in the document. So I think one item was, again, let's just reiterate on prefix, but I think all of us agreed now. Next is what we need to return or from this method, whether it's a refund or the used amount. Let's have a vote and like discuss this for.
Eugene, two things.
Before-
The mic question was really interesting. Maybe everybody will ask the same question, and you can put your answer in the standard, so people can be assured that the then callback will be executed.
Oh yeah. Okay.
I'm happy
I
to
made
add
a
that.
proposal.
Can you repeat this?
Maybe we can add to the standard the same clarification you made about the gas for the callback, for the then
Oh,
callback.
okay. Yeah. Sounds
I
good.
made a proposal at the end for the change in the return value.
Sounds good. Yeah, let's vote on this and
Okay, so before
in
voting,
the final.
before voting, I just want to ask: does anyone has a strong preference with an argument for one or another option, except Lucia, who we already listened?
It's not a preference for me. It's a natural thing to do. It's evidently natural. I don't know. It's not choosing a color.
Okay. I mean, so basically it will say the method should return the amount of tokens that has to be refunded to the sender. That makes it fairly clear.
Check it at the end.
Yeah.
I rewrote that part.
Okay. Should return the amount of unused tokens. Exactly. Yes. So it makes it fairly clear, right? You return 0, you return 50, and you return like is a 500 to panic. You're saying the method should panic. Yeah, sounds good to me. I think, yeah, that's not bad. Final thing, we switched to one Yocto requirement, right? We decided, like, I think everyone agrees on this. Until we fix it in the wallet, we should do this in this given standard. It's not gonna affect anything, except it will prevent a front end from issuing it through the access key.
And I think it's very important.
Sounds good.
Yep.
Eugene,
Okay.
a question: is in the roadmap to change how access keys are managed?
It requires metadata on a contract. The contract will have to say which methods are secure, which methods are not secure. So when you authorize this access key on the wallet side and you say, I want all methods, it will say this method requires you to get confirmation every time. Do you really want to add this access key? Similarly, how you need to confirm a full access key transfer, like you need to type your account ID. So we can do the same once a contract metadata exists. This is different contract metadata from a fungible token metadata. It has to be generic contract metadata that we plan to work on. So yes, it's in the roadmap, but it's far away. It's probably like Q2 because we first need to like complete a full metadata work.
Okay, great.
Agree everyone and like start switching contracts to this metadata. But yeah, the metadata work is super cool and like it will be extensible, like can solve a ton of problems, including tools, front-end interfaces and stuff like this.
In this final minute, Al or Trevor or James, did you guys have anything to add? Thoughts?
No, looks good to me.
I have a question, but I'll ask it earnestly.
Okay, I have one more thing. Let's not use should. In many places we should, let's use must, uppercase must. Like there is this RFC, way how we describe things. And yeah, I suggest that we use must must not, and may. That's like a standardized language for expressing what can be done, what can't be done, and what may be done.
Okay.
Like, so in
must,
general, like
may, and what?
Must not, and may.
Sounds good. So, okay, I think let's summarize this in this issue. The final proposals that we do, then once we're done with this, let's redo the top level piece here to indicate all the proposals that are accepted, and then polish it for the text. But as for API, we will get it locked fast. And then once everyone like polishes my language, then we should be good to go. And I will put it in Nomicon, similar how we have fungible token here. So we will deprecate this token and put a new token standard. So we'll call it like deprecated legacy fungible token and put it in Nomicon as well. Then build a few implementations, one for assembly script, one for Rust, and link them there as well. And that should be good. At the same time, we can start working on the next two standards that are required for this, such as metadata and account registration.
Yeah,
and
but
eventually we'll add events.
Then we will need to upgrade that standard, because this standard have to implement metadata and have to implement the account registration.
Right. Yeah.
So we will need to like,
in order for this to work, then we need to add both of them. Yes.
Yeah, that this trait has to extend to a few other things.
Yeah. So yeah, we'll need to indicate it in Nomicon as well, saying a complete fungible token contract has to implement 3 following naps. So this is like current version. We'll name. We should probably like give a version for the like something like 1.0 and point to the 3 standards that need to be implemented. Eventually, we'll add events once we have binary events on chain.
Well,
yeah, go ahead.
No, I was just like saying that we can even mention here like yes in the somewhere in the preamble.
This standard.
Yeah, somewhere in the preamble.
Yeah, sounds good.
Explaining that
Yeah, we'll update this and point to the next 2 that like currently focuses on. Sounds good.
Right, like, but
we can create placeholders for now, so there's already issues pre-allocated, so we can link it before we finalize this one.
Exactly.
Also, cool. Al, thank you, Al, for having this be very clean and having the idea of just like proposal change rejected. That worked out really well for this. So thanks.
One more thing. Let's not use issues. Discussions are much better. We already have the discussions are enabled in the repository. I would suggest that we ban issues. I mean, issues
to have discussions.
So the difference between the discussion and the issue, I mean, clearly this thing should be a discussion. Why? Because discussion is threaded, right? Here, if you want to respond to someone, you need to scroll, quote, and all these things.
Can you reply? Oh, yeah, you can reply. Yeah, that's better. Yeah, let's go for discussion.
The issue should be reserved only if there is like a clear link to the pull request. Right? I'm just saying that okay, things related to a task. If I want to define a task and then work on it. But
okay, let's actually migrate this to a discussion. I will link a discussion from this issue and later close it once, and let's put it all into discussion and then link it back as well. So for this particular, but all future standards should go to discussion.
Exactly. And
you have to update the instruction then to propose a standard.
Right. Right. Yeah, we'll need to probably link it as a top of discussion and like put it into docs as well.
On
Good
the
point.
README.
Is it a README map? I think it's actually pretty old because it still talks about template, and we don't use templates anymore because they're cumbersome. So maybe you should update the template as well. Yeah, good point.
Like all documentation gets outdated. Yeah.
Right. Okay.
Okay, sounds like we are done.
Yeah. Thanks everyone for
Yeah, thanks, folks.
contributing.
Yep, very
It's
cool.
great that we.
It was
Good work.
great.
Thanks.
Bye.
Thanks, Joe.
Okay. Bye.
Bye-bye.
Mike, you probably need to stop streaming first.
Yeah, I'm trying to figure this out. I think I did. No, it's live. Actually, can you make me host again? I think maybe that'll give me the option I need.
Let me just leave and make you